Alright, welcome to another Robolink tutorial on drones. Today we're going to be covering lesson 7, which covers trim and how to actually send commands to your robot so that you can trim it. This one is actually, compared to all the other ones, this is quite a doozy. Mostly because there's a lot of things that we got to check in order to make it work. Uh, so that being said, we're going to jump right to it. So up on the screen I have added the library that we always use at this point. Smart drone control.h. Lovely library. I have also included on setup serial.begin, smart drone control.begin, and a small delay. Again, very familiar, isn't it? Alright, so with setup out of the way, we're now gonna jump into the loop. Now, as I mentioned in the beginning, we're gonna be doing lesson 7. So, we're gonna be using the number 7 for our smart drone control lesson. Oh, there we go. I can type. Apparently not. Okay. Lesson 7. So this is gonna disable everything. It's only gonna disable the trim. So, for trim, we're gonna check the state. So if you watch the tutorial on the flight select mode, lesson 6, you will not remember that we had if statements in order to select between flying and trim. So the first thing we're gonna check is are we in the state of trim? That means that the person using the drone is controlling is putting their finger on the sensor and leaving it there. Now, the first thing we're going to check, alright, little background. What is trim? So trim is essentially, as I described in one of the previous videos, all robots have tendencies. They want to lean in one direction or the other. And so, sometimes we have to compensate for those tendencies. Why they're doing that, there can be many factors. It can be because the drone's motors were not all the same, the propellers are slightly used, and some of them are newer. Pick a reason. Regardless of the case, we want to be able to compensate for any issues that might happen, which is the case of what we do with trim. So if our robot is moving in one direction every time we take off, then we can trim in the opposite direction, essentially making the robot know that it's going the wrong direction each time. So we are only going to trim 3 of the main things that we control in our drone, which are yaw, pitch, and roll. We don't care about throttle. You don't really need to trim that. But yaw, pitch, and roll you do. Now, what do I mean by trim? Like an example. If you have a drone and every time it takes off, it starts veering off to the one side, to the right, you need to compensate to the left. That means that every time it flies off, each time you trim it, you're going to trim it so that each time it takes off straighter and straighter. And that's what we're writing. So the first thing we got to do is we got to check those 4, what the inputs are for what you want to trim, right? So we're going to check the joysticks and we're going to see, okay, is he trying to trim yaw? Is he trying to trim pitch, or is he trying to trim roll? Now, regardless of which one you're trying to do, you're going to write it to that value. Next, we're going to check, okay, now, it is a lot of code, so I am doing quite a bit of copying and pasting. So if you see code suddenly appearing, it's not magic. I'm just copying and pasting from something I wrote before. Now, each time we're checking, okay, has the pitch gone back to its original position? This is actually important. Each time we check, okay, is pitch back at 0? Yes. Okay. Change this variable that we are controlling in our library to 0 as well. Now this is going to be something that we use in order to prevent over pitching or over compensating for one direction. If you're leaning to the right, you don't want to increase it so much that you start leaning to the left, because that kind of defeats the purpose. Well, in order to keep track, okay, we trimmed to one direction once. All right, let's wait for them to reset the joystick back to 0, and then do it again. Probably will make a video on how to trim and everything later on. Um, so this will make a little bit better sense then. Another thing, okay, so these are us grabbing whether the person is trying to trim in that direction. So did he move to the left or to the right? The joystick to the left or to the right? Up or down? And then this is, have they gone back to the original position? Now we're going to check the actual things, the actual values that we're reading, right? So in essence, we're going to have one for each possibility. So you can be to the all the way to the right, all the way to the left on the for your pitch, for your roll. For your pitch, you can be all the way forward, all the way backwards. Your yaw, you can be all the way to the left or all the way to the right. At least the way that my controller is connected. So for each of them, we're gonna check, okay, and they're gonna be else's. Is the pitch greater than 90? Is it less than negative 90? Again, we don't wanna make it so that every twitch that we might have with the controller might cause it to trim in this point. We wanted to make it a conscious decision. Alright, he moved his joystick all the way to the left. That means he wants to change that. Otherwise, it might create situations where, again, you're overcompensating for something. And we're going to have an if statement for each of them. So one for roll, one for pitch, and one for yaw. So I'm just getting it out of the way. So this one is for less than negative 90. There we go. Exciting watching me type all of them, right? And the final one is yaw. Yaw. Greater than 90. There you go. And the last one is if it's less than negative 90. Like that. So each of these is going to have something inside of them. And the stuff inside of them is actually going to look pretty similar. And you'll see how in a second.